1.01 to the power 10 lakh versus 10,000. Which of these two numbers is greater? Pause the video, try this on your own. Alright, the clue here is we're going to use binomial theorem for this. Some expansion will happen. Alright, let's do this together. 1.01 to the power 10 lakh. We can break down 1.01 as 1 plus 0.01. Now this is of the form a plus b to the power n, and more specifically, this is of the form 1 plus x to the power n. If you want to remember what 1 plus x to the power n is, so this is the expansion. 1 plus x to the power n, that's equal to nc0 x to the power 0 plus nc1 x to the power 1 plus nc2 x to the power 2 plus so on till ncn x to the power n. The coefficients are nc0, nc1 and so on, and they have increasing powers of x to the power 0, power 1, power 2 and so on. So how are we going to use this to find 1.01 to the power 10 lakh? But before we move further, here are a few points. N here is a very large number. We have n as 10 lakh. This means we have 10 lakh plus 1 terms here. Do you think we're going to be able to find the values of all 10 lakh plus 1 terms? Definitely not. But we don't need to. At best, we'll find the value of the first few terms, approximate where this is going, and then compare it with 10,000. So let's do that. The first term is 10 lakh C0. X here is 0.01. So that's going to be 0.01 to the power 0. The next term is 10 lakh C1 multiplied by 0.01 to the power 1. The next term will be 10 lakh C2 times 0.01 square and so on. The last term will be 10 lakh C 10 lakh times 0.01 to the power 10 lakh. Very big expansion, but let's begin. The first one is 10 lakh C0. Anything C0 is 1, so this is 1 times 0.01 to the power 0, that's also 1. So this is 1. Let's take the next term. The next term is 10 lakh C1. Anything C1, well, it's that same thing. So this is going to be 10 lakh times 0.01. Wait a minute. What is this? 10 lakh times 0.01. What is the value of this? Well, if you multiply these two, you get rid of 2 zeros, you'll get 10,000. So this is 10,000 right here. We have 1 and then we have many more terms. We actually don't need to evaluate anything else. We have our answer in front of us. Do you see it? Okay, so let's wrap this up. This is 1 plus 10 lakh times 0.01 plus a lot of terms, but I'm going to just write something positive here because all of them are positive. So let's write something positive. They may be very big or very small, but as of now, I can care less. This is 1 plus 10,000 plus something positive. We were comparing this with 10,000. We already have 10,000 and some more. So this number 1.01 to the power 10 lakh, this is definitely greater than 10,000. So this is how we use binomial expansion for this type of comparison. Let's take one more. Next is 1.1 to the power 10,000. Let's reduce the power by a lot and compare this with 5 lakh. Let's increase this number. Maybe now we have a fair competition. Pause the video, try this out. Okay, so let's do this together. We'll expand 1.1 to the power 10,000 as 1 plus 0.1 to the power 10,000. Let's do that. This is equal to 1.01 to the power 10,000. Again, same thing. 1 plus x to the power n. That's nc0 x to the power 0 plus nc1 x to the power 1 and so on. Okay, so n here is 10,000. We'll have 10,000 c0 times x to the power 0. X here is 0.1. So this is 0.1 to the power 0. Next term is 10,000 c1, 0.1 to the power 1. Then we have 10,000 c2, 0.1 square. Maybe we don't even need this, but I'm just writing it down. Plus a lot of other terms. Last term will be 10,000 c 10,000 times 0.1 to the power 10,000. Again, we don't need to evaluate all of these terms. we want to get an idea of where this expansion is going so that we can compare this with 5 lakhs. Let's look at the first term. We have 10,000 C0, that's 1, times 0.1 to the power 0, that's 1. So 1 times 1 is 1. Next is 10,000 C1, that's 10,000, times 0.1. What is this? This is 10,000 times 0.1, that's 1,000. 1,000 is way less than 5 lakhs, so I think we need to keep going. Let's look at the next term. 10,000 C2. What is this value? This is 10,000 times 9,999 divided by 2. That's going to be 10,000 times 4,999.5. That's going to be 4,995,000. This will be 10,000 C2. Times 0.1 square, well, that's going to be 0.01 plus a lot of other terms, but I don't think we need them because this is a very large number. So I'll write something positive here. Okay, let's see what these three terms are. This is 1. This is just 1,000. What is this? This is 499,950. So 4.99 lakhs approximately plus something positive. We're comparing this number with 5 lakhs and we're almost there with just this term. This is 4.99 lakhs or 499,950. In fact, this is just 50 less than 5 lakhs. So if you look at these terms, all of them are adding up, you'll get something definitely greater than 5 lakhs. So even in this case, the power 1.1 to the power 10,000 is way bigger than the number that we had, 5 lakhs.